Hi, and welcome back to Dental Snippet. In the first part of this video, we discussed the composition and the manufacturing process of the atomized spherical powder. In this part, we will be discussing the manufacturing of the lathe-cut amalgam and a comparison between the spherical and the lathe-cut amalgam alloy. The lathe-cut powder is manufactured by melting all the elements of the amalgam alloy. This molten metal is passed into a mold and rapidly cooled to form an ingot. Now, since this ingot is rapidly cooled, the core of it has a certain composition and the surrounding areas have varying compositions. This is now known as a non-homogenized ingot. If we were to cut up this ingot, we'd get part of the core, which is the silver tin phase, and the rest of the powder would have more silver in some areas, more copper in some areas, and more tin in some areas. In order to achieve the same silver tin phase throughout the amalgam alloy, the non-homogeneous ingot undergoes a homogenizing heat treatment. For this treatment, this ingot is placed in an oven just below solidus, which is basically the highest temperature possible where it remains a solid. It is kept at this temperature for sufficient time to allow for diffusion of the atoms. This results in a homogeneous ingot. Now this ingot is quickly dipped into cold water to cool it down. This ensures the phase distribution remains unchanged. This process of quick cooling into cold water is known as quenching. Now, if any part of the powder is checked, it would have the same silver and tin phase as we discussed before. This quenching results in the formation of maximum beta phase, which is the silver-rich phase. Now, this ingot is cut or milled in a lathe to give chips of the lathe-cut powder. These chips may be needle-like and may be reduced in size through ball milling. Now, these particles have been through so much that there are stresses induced in them. These stresses must be relieved as they may cause change in the alloy characteristic. These particles now undergo a stress relief process which is known as annealing, where basically they are heated at a moderate temperature for several hours and cooled gradually. These relaxed powders may also be acid washed to make them more reactive. Both the lathe-cut powder and the atomized spherical powder have their merits and demerits. The smaller particle size of the spherical powder may make it easier to pack into small areas and allow for easier carving and polishing. But the lathe-cut powder possesses body and gives the amalgam restoration good fracture resistance in areas such as proximal restorations. To combine the best of both worlds, admix alloy powders were introduced, which contained 2 parts by weight of the lathe-cut powder and 1 part by weight of the spherical powder. To conclude, we've attached a combined summary for both parts of the lectures. Feel free to screenshot any of the slides you'd like. If you have any suggestions, do write them down in the comments. If it's been helpful, please like, share and subscribe. Thank you.